Good day, ladies and gentlemen. This is Sarah van Gr8, aka Mr. VG, and this is arguably one of the most important sections of work you will do in your whole grade 8 syllabus. I know that I sound super dramatic when I say this, but that's fine, because it really is. If you mess this up in grade 10, 11, and 12, even in grade 9, oh my goodness, I'm telling you now, you are not going to pass mathematics. And it's not me being dramatic. I've seen it so many times that kids struggle with this concept even to grade 11 and 12. And then they struggle with everything else. So please make sure that you watch this video, practice, and ask for help as much as you can. So we are going to look in this video specifically at the concept of like and unlike terms. Now, if you're not sure what terms are, go and watch the previous videos where I speak about terms and polynomials. Oh man, it was so much fun making those videos. Let's talk about like terms. Well, imagine you have two bicycles that you add together. One bicycle, let me go at the slower, one bicycle plus another bicycle. Well, duh, sir, that's two bicycles. Now, if I write this out, I'm basically saying one bicycle plus one bicycle equals two bicycles. Oh man, that is so simple. But what if I talk about boxes? One box plus two boxes gives me, you're right, three boxes. Now let me do a sneaky. What if I put that in a form that looks like this? You still all right? One box plus two boxes equal three boxes. Yes, you've got this. But what if I put something in the box and in every single box I put the same thing? Now I put an X inside every box. How does this sum now look? Well, I've got one X and then I've got two X's. Add them together, it gives me three X's. Or one box with X's plus two boxes with X's gives me three boxes with X's in them. But what if I try to add a box plus a bicycle? What kind of a sum is that? Well, ladies and gents, it's exactly the same principle of saying X plus Y. I cannot add them together because it is two completely different things. It's like saying I'm adding an apple plus a 5-star chocolate. Oh my, now I'm less for 5 stars. Oh my goodness. An apple plus a 5-star chocolate. What does that add up to? Well, one weird diet, but in any case, it doesn't make sense. So they are unlike terms, and we cannot add them. So when we look at an example, and I'm going to do these three examples in this video, and I'm going to take you step by step through these examples. So let's start with example 1. 3x plus 6 minus x plus 4. So what I want you to do in your mind is group the like terms. In other words, put the like terms in the same kind of decoration or color. If you've got highlighters, use highlighters. But I like to put things in boxes and squiggles and triangles to make sense of it all. So 3x and the x I put as boxes. So I can see that they are like terms. It's not just that there's an x, but that is 3x, a negative x. So I like to reshuffle them so it makes a bit more sense for me. So I like to put my x's at the beginning, my constant terms at the end. Now I go and I ask myself, if I've got 3 boxes and I subtract 1 box, so 3 box minus 1 box, well, that's 2 boxes. Now the same with the constant terms. Positive 6 plus another 4. There's 10. Now, I cannot add 2x and 10 because they are not like terms. Now, how do I know whether it's like terms or not? Look at the variable part. There's an x, but there's nothing behind the 10. So if there's nothing behind the 10, let me rather use a different color, then it's not like terms. So I've got 2 boxes plus 10 screws. Doesn't work. So I leave it as is. Ta-da! Now you go and try question 2 and 3, and then you unpause the video and you look at the rest. Now question 2, I'm going to put the x squares in triangles, the x's in boxes, and then that random little plus 1, the constant, I'm going to put as a line under it. So let's put the triangles together, so the x squared. And then I'm also going to put the boxes together, the negative 2x and the negative 4x. You see I move the sign with it. So negative 2x still stays negative 2x. Negative 4x still stays negative 4x. And then I've got that random plus 1 at the end. So now I'm going to add my triangles together, my boxes, and the random little squiggly there at the back. So 1x squared plus 1x squared gives me 2x squared. Again, don't let the squares confuse you. 1 box plus 1 box, or 1 triangle plus 1 triangle is 2 triangles. It doesn't become super triangles. It's still triangles, still x squared. The same with the x's. Negative 2x minus another 4 gives me negative 6x. Remember that you can always use a number line. Negative 2, subtract another 4, negative 3, negative 4, negative 5. I end up at negative 6. Don't forget you've got a timeline. Maybe write one out and use it. Last but not least, the plus 1. Again, the x squared, the x and the 1 is 3 different terms, not the same, not like terms, so unlike terms. So therefore, I cannot use them, cannot add them up. I mean, not use them. Oh my. Oh, let's focus. Let's push through. Question 3. I don't like question 3 because there's a little bit of a mess up there by the last 2 terms. So let's first rewrite them. So I'm just going to go and swap the x and the y. So can you do that? Yes, you can, because remember it's y times x. I can swap around an x and a y. I don't like the whole thing of xx. So remember that xx means x times x. Well, that's just x squared. Now, what are my like terms? Now we've got, look at the variable parts. I've got an xy that I'm putting in boxes. The x is a circle, and that x squared is a squiggly. A squiggly x squared. Oh my, I'm loving this. Then I'm going to shuffle them around. I'm going to put the like terms together. So 1xy plus 4xy, so 1 box plus 4 boxes is 5 boxes. Then I've got negative 2x and negative 7x squared, and that's the end of it. Oh, what a lesson this, guys. This is so crucial that you get this. Please make sure, put your things in boxes. Just add and subtract the like terms. Please, please, please. This is Sarah van Gr8, aka Mr. VG. Tune in to our next one where we are going to look at distribution of algebraic expressions, and then after that, division. So have a beautiful rest of your day. Cheers.